All right, guys, so we're going to start working on something we've been doing a lot of in class, which is proving whether or not two triangles are congruent or the same. So looking at this diagram, we're given quite a bit of information. Okay? Right here, these two little check marks and these two little check marks mean that those two sides are congruent. They're the same length. And same thing down here, we've got one slash mark and one slash mark, so those are the same. Okay? And to show our thinking, we're going to write these out in a statement reason table. So if I look here at the two slash mark side, that's AB, and it's congruent with this other guy over here, AC. And how do I know that? Okay, I know that because it's marked on the drawing, so I can say that that's given to me. Right? Whoever made this problem gave me that information. Okay? Same thing down here, we've got CD and DB. Okay? And once again, I was given that information. Okay? And as we look here, none of my angles are marked. Okay? So the other piece of information that's a little bit harder to see is right here down the middle from A to D. Both of those triangles use that same side, so that side has to be the same length in both triangles, right? It's the same line. Okay, and we're going to write that AD is congruent with AD. But our reason, that wasn't given to me. Our reason on this one is because it's a shared side, right? It's shared by both triangles. So I'm going to write shared side. Okay, and now I've got three pieces of information. I know these sides are congruent, I know these sides are congruent, and I know I've got a shared side, so I can say that my triangles are the same. So triangle ABD is congruent, and I got to go in the same order. So when I did ABD, I went down the side with 2 and then down the side with 1. To do that, to follow that same pattern, I'm going to go down the side with 2 and then across the side with 1. That's going to be triangle ACB. Okay, and I know that these two triangles are congruent because I showed that this side, and this side are the same. So I will just say side, side, side. Skirt! And I made a mistake. This should be ACD, not ACB.
As we've been discussing in class, there are 4 triangle laws that allow us to prove that triangles are congruent. Mr. Matthews just went over the first triangle law, side, side, side. So that's one piece. But let's look at what we see here. We're once again going to look at what we're given, and we're going to construct our statement reason to see if we have the evidence to use one of our triangle laws. So just like Mr. Matthews said, I see that this side has 2 little tick marks, and that side has 2 little tick marks. So that means that the 2 sides that have those 2 tick marks are congruent. So HP is congruent to PM, because they both have 2 little tick marks on them. And the reason for that, the problem literally gave that to you. It's already marked up. So I'm going to say given. Now we have another side that has 3 little tick marks and 3 little tick marks. So I know that NP has to be congruent to PO, because they each have 3 little tick marks. NP will be congruent to PO. And that once again was given. But as I look up here at my drawing, I don't have any other little marks anywhere. So I'm not going to have another given piece of evidence. But using triangle law, we have to have 3 pieces of evidence before we can say that 2 triangles are congruent. So we're going to have to ask, do you see something that we've already learned about before? And I see right here, I see a pair of vertical angles, which we know are congruent. Now I can't just say angle P is congruent to angle P, as I don't know which angle that talks about. So we have to use our 3-letter way to name the angle. So if I'm going to name this one, that has to be my middle letter. So it'll be angle NPH. Angle NPH, make sure you use your little angle sign, is congruent. I need the 3 letters for this one. Once again, that P is going to be the middle letter. So I'll go MPO. And what was my reason? It wasn't given. We used previous learning because we know that those are vertical angles. Now that I have 3 pieces of evidence, I can ask myself, do I have enough information for triangle math law? And we do. As we see a side, an angle, and a side. A side, an angle, and the side. And the angle I know about is in between the 2 sides I know about. So this is going to be my side, angle, side SAS law. Now let's name the triangles that we know were congruent with SAS. I'm going to say NPH, triangle, NPH. That's why it's important to use your correct symbols here. And I have to do the same order. The order matters. So if I went down the side with 3 and up the side with 2, I have to go down the side with 3 and down the side with 2. So I'm going to say OPM, triangle, OPM.
All right, guys, so Mr. Bakke just talked about side, angle, side, and I, in the first part of this video, talked about side, side, side. So let's look at another example, okay? And same thing as we did before, we need 3 pieces of information to prove that these triangles are the same. Okay, so when I look at these, this time I'm given some stuff. I'm not given 2 sides like in the last 2 problems, but I am given 1 side. So let's start with that. We know that NL, this side right here, has 1 check mark. Okay, the other side with 1 check mark or tick mark is this one down here, which is JH. So we're going to say that NL is congruent to JH. Okay, and same thing as before, right? The problem gave those to us, so we're just going to say that they were given. Okay, so there's our first piece of evidence. Let's change colors here. I don't have any more sides, okay, but I do have this angle right here and this angle down here. They're both marked with 1 little swoopy shape, which means that they are congruent. That's how we mark angles as being congruent. So I can say that angle L and angle H are congruent, and that is once again given. Right? The problem gives that to me. Okay, but that's not enough pieces of evidence. I still just know 2 things, and I need 3 to prove that these 2 triangles are the same. So same thing as last time, we're going to dive back into our previous knowledge, okay? And when I look at this problem, I see right here in the middle, I've got angles on opposite sides where 2 lines cross, which means those have to be vertical angles. Okay? And I can't name these as easily as I did on this last one because there's a lot of different angles here in the middle that I could mean when I say angle O. So we have to use the 3-letter naming convention, just like Mr. Bakke talked about. Okay? So O has to go in the middle, and I can name this one LON or NOL. Okay, so angle LON is congruent to HOJ. Right? Those 2 blue angles are vertical angles. And now I have enough to say that these 2 triangles are the same. So let's look at what we actually do have. We have this side on the bottom, we have an angle, and then we have another angle. Okay? So for this to be angle, side, angle, we would need the side to be in the middle, and it's not there. Okay? So we have to be really careful with our order here. I've got an angle, and another side. So this one's actually going to be AAS or SAA. Either one of those is a fine answer, right? It's just looking at it the other way. Okay, and now we just have to name our triangles. So if I start here, we'll call this one triangle, right? Use your little triangle shape. NLO. Okay, we started here, we went across the side with 1 tick mark through the angle that was marked to the middle. So if we do the same thing down here, it would be across the side with 1, past the angle that's marked and into the middle. This would be JHO. Okay, so I proved my 2 things were the same using AAS.
We have one more math law that we need to learn that can prove that 2 triangles are congruent. We've talked about side, 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 angle, side, and angle, angle, side, but we have one more that we're going to see right here. Now in this case, my given information wasn't marked up, it was in statement form. So I'm going to need to read this and mark it up before I go to my proof. So this says that BC is congruent to CD. So I'm going to find BC and put 1 little tick mark. Then I'm going to find CD and do another little tick mark, because that's how we show that 2 sides are congruent. And now I can go ahead and just write that straight up into my statement reason table. Because you can get given information either with the drawing already marked up or in statement form. So we'll have BC, not DC, BC, geez, is congruent to CD, and that was given to you. The other thing we know is that angle 2 is congruent to angle 5. So I'm going to find angle 2 and put a little arc. Angle 5, I'm going to put a little arc. And since these are nicely numbered, I'm just going to use the numbers for the angle. Angle 2 is congruent to angle 5. Once again, that was given to you, even though I had to mark up my own shape. That was given. Now, there's no other pieces of given info, but we need 3 pieces of evidence to use triangle law. So once again, think about our previous learning. I see another pair of vertical angles that are opposite each other when 2 lines intersect. So I'm going to do 2 little arcs to make sure I understand which ones are different. And I see that angle 3 and angle 4 are now congruent. So angle 3 is congruent to angle 4. That wasn't given to you. We knew that because those are vertical angles. Okay. I see I have 3 pieces of evidence, so let's see what math law we can use. Here, I have an angle, a side, and an angle. An angle, a side, and an angle. And what's important here is the side we know about is in between the 2 angles we know about. And that's why we can say angle, side angle here. Because the side is in between the 2 angles that we know about. Now let's name our triangles. Up here, I'm just going to say triangle ABC. Triangle ABC is congruent. So here, I went to the side with 1 arc and down with the 2 arcs. So down here, I'm going to go to the angle with 1 arc and end with 2 arcs. So triangle EDC. And now we have all 4 math laws that you're allowed to use when talking about triangles being congruent.